To find a general solution to a first-order linear differential equation, the textbook has done the heavy lifting for us. Okay, if we can find an integrating factor in terms of x, so like m of x, we can follow this process to find an integrating factor, then this can be our general solution. We can find out what y is. This would be the general solution. So before we do that, we need to be able to identify what p of x is. That means we want to put this in standard form for a first-order linear differential equation. Okay, so there's standard form. So we're a little bit off from there. We need to move x. Let me see if I can zoom in. We got to get rid of the x, so we just have y prime on this side. So since things are already in terms of negative exponents, well, this is tough because this is also a fraction. Yeah, let's think about this as multiplying both sides by x to the negative first, because x to the negative first times x to the first makes 1, right? So this is our goal. I want to put it in standard form. We get y prime equals x to the negative third, because x times x, the powers would add up. And then here, this is actually going to be my 7y over x squared in the denominator. Because this, another way of writing this fraction, is 7x to the negative first y. It's x to the negative first because it's in the denominator. So negative first, x to the negative first times x to the negative first thing makes x to the negative second. So that's how I arrived there. And we're still trying to get the derivative of y with respect to x and y all together on the left side of the equation. So I'm adding 7y over x squared to both sides. And we're almost there. Let's see. So yeah, we need to just clearly identify a p of x, so a function in terms of just x. Let's keep the 7 over there, and then there's our y. Right, so all I did in this step is I rewrote this fraction. Same thing, right? Because you'd put a 1 underneath this y and then multiply straight across the top. So now it's in standard form. Now we know what p of x is. And we know what q of x is. So now we can use what the book's given us. We can find the integration factor. And it's the indefinite integral of p of x, which is 7 over x squared with respect to x. So m of x equals, now think about this antiderivative. That's 7x to the negative second. So the antiderivative there is going to be negative 7x to the negative first. Now that we have the integrating factor, we can go to the general solution formula. We want to find y. It's 1 over that integration factor. And that's times the integral of the integrating factor times q of x, which is x to the negative third with respect to x, and then plus some constant c. Let's see, so evaluating this indefinite integral, what can we do here? I think I know what we can do here. This is y equals 1 over e to the negative 7x to the negative first. Let's think about a u substitution. Maybe we can get by it, because I'm thinking integration by parts would be pretty tough here, and I don't think it would work. Because if you call this u and call this dv, it's dv is going to continue. You're going to be able to keep taking the antiderivative of that. It's not going to stop. There's no ending point there, and there's no trick to get out of the loop. What if u was 1 over x? Because that would take care of this. This is x to the negative first. So that's 1 over x, right? So the entire exponent would be substituted. And think about what du would be. Du would be negative 1 over x squared. And so here, if we expand this, this is the integral of e to the negative 7x to the negative first times, this is 1 over x times 1 over x squared, you can think of it as. And there's that arbitrary constant c. right? This is like our u, and then we're going to have something close to du. We can just factor out a negative sign. So now we're ready for u substitution. Remember, we're not substituting out here because this is not part of the integral. We took out a negative sign. This is the indefinite integral of e to the negative 7u. And then this is times, this is our u, and then this is our du. So we can integrate that. That one's going to take integration by parts. So let me clear the board. Take a picture. I'll clear the board, and we can start from there using integration by parts. Okay, so just a recap of where we're at with this problem. We use the formula derived from the book to find a general solution for a first-order differential equation. This is where we're at. We're trying to evaluate this integral, so we want to use integration by parts. And remember, with integration by parts, you want to define a u and a d. Here, I'll put the formula up. The integral of u dv is equal to u times v, which is not what we have in the original part. We have to find v, minus the integral of v du. Okay, so it's a little confusing because we have a u in here. Let's just say this was L for our variable instead of u. Let's call these L's. Actually, yeah, because we don't want to call it X. Okay. So when we're trying to do integration by parts, we want to let u be something so that when you take its derivative, it could turn into nothing. You know, it could turn into a constant. So let's let u be that capital L that we see in there. This L right here. This will be our u. And so that means for the first step, we make a u and we make a dv. So our dv has to be, the other portion has to be e to the negative 7L. So we can find out what du is. The derivative of u with respect to L is just 1. And then v would be the antiderivative here, so that's just going to be negative 1 over 7 e to the negative 7L. Okay, so now we have u and dv decided on for integration by parts. This is now going to be, here, I'm going to put this all in another set of brackets. This is u times v, so this is going to be negative 7L, we're calling it, negative 7L. Wait a second, no. Negative L over 7, right? Just u, which is L, u times v, so that's negative L over 7 e to the negative 7L. And then the integration part, we got that part done in the formula. Now we're supposed to do minus the integral of v du, so minus the integral of v du, which is just 1. And so that's an integral we can evaluate having to use any calculus tricks. Okay, so I'm going to distribute this negative sign so I don't have to have extra brackets here. Oops, and I even forgot one. Oh, plus c. There, that completes that top one. So distribute that negative sign. So this is L over 7 e to the negative 7L minus, so distributing the negative sign makes this be a plus, but then when you take out the other negative sign, brings it back to a minus. And we have 1/7, and it's the indefinite integral of e to the negative 7, so that's negative 1 over 7 e to the negative 7L. And then plus the constant c, but that'll just absorb into the other arbitrary constant we have, c. Getting closer. Now we can go back. L, that was our original substitution. Remember, we let everything be, we replaced all the x's with, we said u before we changed the u to L. That was 1 over x. So that was our original substitution. So it means L is 1 over x, because that was our replacement. So this is 1 over x divided by 7, so this is an easier way of writing that. And so that's when we plug in 1 over x there. And now a negative times a negative makes a positive. And then this is negative 7 over x plus some constant c. Getting closer, getting a little bit better. These can't combine because they're not perfectly like terms because of the x in the denominator here. But we could distribute this. We could distribute the 1 over e to the negative 7x to the negative first to everything. Let's see, so if you multiply this times this negative 7 times x to the negative first, that's negative 7 over x. So it's e to the negative 7 over x divided by e to the negative 7 over x. So that's going to cancel out and leave us with just 1 over 7x. And then when we distribute here, same thing. This is going to cancel out this term. Looks like it's 1 over 49. But then we have this constant term that we have to multiply to. So that's going to be c over e to the negative 7x to the negative first. So this is the solution, but I just checked. It looks like WebAssign is a little bit picky with how it's entered here, so just wanted to make a note. Look, you can get common denominators to combine these fractions. Okay, actually, I can fit that underneath. Multiply the top and the bottom of here by 7. Multiply the top and the bottom here by x. And then here, this is a negative exponent, so you can write it like this. Right? Because if you have a negative exponent in the denominator, you can make it be a positive exponent by moving it to the top, to the numerator. Just separate those with a line. And then now we have common denominators here. This is how they're writing the answer. Same thing as what we got. It's just, I don't know, I guess you could say that's simplified because instead of having 3 terms, we've got 2 terms. Plus that c times e to the 7, and then they didn't write x to the negative first. They wrote 7 divided by x. So same thing, just written in a different form.